Welcome to this Akima 2021 roundtable discussion. It's titled The Connected Future of Process Automation with Ethernet APL. This year's show, you'll see a lot of discussion around about 10BASE-T1L APL. There is a number of products being launched this year. It's going to have some pretty profound changes to the process industry. We have traditionally been using 4 to 20 milliamp and latterly field bus technologies. Now we're moving to an Ethernet-based technology, 802.3CG or 10BASE-T1L. And then from that, there is a new standard called APL, specifically for the process industry, that's going to bring many, many advantages and changes potentially. So today I'm joined by from esteemed colleagues from the industry. My name is Jonathan Law. I'm the Director of Process Control and Factory Automation at Analog Devices. And my guests are, in no particular order, Michael Kessler is Executive Vice President, C&T Process Automation at Pepl & Fuchs. Michael represents PNF on the APL Standards Committee. I have Guido Koenig, Global Market Segment Manager for Chemicals and Petrochemicals at Samsung. He's been with them since 1993. I have Thilo Merlin, who's TopWorks Platform Manager at ABB. Thilo joined ABB in 1998 and contributes to many of the standards committees and working groups on industrial communications. And then finally, a colleague, Volker Goller. Volker is a systems applications engineer at Analog Devices. He's over 30 years experience in industrial applications and communications. Okay, thank you very much. So the first question I have to the group really is, how does APL differ from the current 4 to 20 and field bus technologies used today? What the changes that we're going to see? I'll start off with the control network side of things. So, Michael, if you have an opinion on that, could you please let me know?
Yeah, I've got an opinion. Yeah, that it's quite a difference, but also has similarities. Today, communication in process industries is based on mainly 4 to 20 milliamp, and process control is just using 1 PV per instrument. And that's going to change fundamentally towards the 4 to 20 milliamps technology. What we have today also is that virtually every instrument has hard communication. That means that there is an option to do digital communication. However, that's pretty limited because of speed and because of the fact that we have a dedicated process automation protocol. And that's the same for the field buses, like Foundation Field Bus and Profibus PA. So what the fundamental change that Ethernet APL will bring to us is that we're going to have a seamless communication that's Ethernet based throughout the plant. So we don't have gateways, we don't have converters to translate between the different protocols. Another aspect is that comes along with the fact that we are now using Ethernet is speed. Communication is much faster than anything we're having today, and that means that this opens up a whole lot of new options. Like you can have very detailed data from an instrument and in a reasonable amount of time. So downloading data through HART was taking an hour. And now we can do that within seconds. Yesterday I heard a comment that's bad for the coffee industry, but it's good for process industries.
Yeah, very interesting point of view there. Yeah. I mean, just with the removal of those gateways, I mean, what are the advantages to the end user, to the end customers?
Getting hold of data that is used outside of the pure simple or the pure basic process control is either impossible or kind of a nightmare. You need to basically define individual data points, install gateways, multiplexers, converters, or whatever, and then manually assign meanings to that data, and then you're able to put that data into cloud. Okay. Users are looking into Industry 4.0, into maintenance optimization systems that are outside of the process control system. The Dynamo open architecture defines a pretty strict separation between process control and maintenance and optimization. From my point of view, that makes a lot of sense, because two dedicated systems that are optimized on their individual tasks are better than one system that doesn't do anything right. So this concept makes a lot of sense, and seamless integration means that both systems can get hold of the data without the need of manual configuration, engineering, translation. Okay. So as an example, the process control system will use the real-time data of the instrument with real-time protocols from the Dynamo perspective, and in the process world that would be either Profinet or Ethernet IP. These protocols are optimized to do that. They're optimized for control, and they're proven in many, many applications. So we're not inventing anything new for APL here. And the second channel to maintenance and optimization to the cloud could be, for example, OPC UA based. Dynamo has defined OPC UA as their interface. There is a PADIM, process automation device information model, that defines how data is represented in the device in a standardized, unified way. And that makes it by far simpler than anything that we've got today.
Okay, thank you, Michael. Thank you. It's very interesting. Thilo, if I just turn to you for a second, in terms of this extra bandwidth and power over the data lines and ability to deliver power to the instruments, etc. What do you see the changes at the field instrument side of things?
I think with the newly available power, we will allow better sensing applications. So we can move computation and signal processing closer to the field, and this is basically where the chemical process takes place. Mm-hmm. And with the new protocol, or with the freedom of the protocol, APL or Ethernet is the first time in the process industry that we can separate the physical layer from the protocol running through that network. Mm-hmm. Years ago, there was even a field bus war mentioned. So, and I think it will help customers really to get an evolution and to grow with new communication capabilities, because the physical layer, one time established, is a stable base and future-proof for the next years. So we will see more innovation, I think, from the protocol side than from the physical layer, like in the traditional Ethernet. An Ethernet device from the 90s still works today. Mm. And even multiple protocols can run through the same network, which is also a novelty compared to the conventional instrumentation. This means we might have different protocols using and sharing the same network, where Michael mentioned already OPC UA, which is dedicated for maintenance and optimization. But I see also classic IT protocols like MQTT might be used. Even today, not really common in that area. In parallel to the traditional communication, let's mention here Ethernet IP or Profinet. So that's for me a big change, and all of that is for the IT world not so new, very common there. But the hazardous area was always a hard border for those technologies, and thanks to LPL, we have now overcome this border or this burden, and we bring this kind of technology into that critical area.
Yeah, I think that's a really good point. This is it's not your IT domain; it's definitely the OT domain technology these days. So set of standards really designed for use in field and in hazardous areas, just enabled by technology that happens to be able to use Ethernet standards to make it a standards-based and so hopefully seamless end-to-end from data creation to the cloud transportation layer. So I think that's really important.
I would like to add on that because I think that is.
Please go ahead.
Ethernet is to the industry like a box of candy, a lot of different candies inside. So you can pick Profinet, you can pick Ethernet IP, you can pick OPC-UA, you can IT protocols, MQTT, yada, yada, yada. So there is a lot of excitement that enables a lot of innovation. So people will look at things different than they did today. Will all the existing protocols, OT protocols go away? Certainly not. Will new things come? Yes, certainly. But there will also be a phase of reconciliation after a couple of years. I think we will have a great future in front of us. There's a lot of things to explore and find out. And that starts innovation.
So we talked a little bit about the sort of the changes that the APL is going to bring. What about the benefits that those changes will deliver to the market? I'm going to switch across to Guido. Guido, could you give me your inputs on this?
Absolutely, thank you, Jonathan. Yeah, it's really a major step, and if we compare to the mainly existing just 4 to 20 milliamp technology in the running process plants, it's really APL offers high-speed connectivity together with universal communications. So it's really the base for services to run all the industrial processes more reliable and with higher output. So in addition to the precise control, it's monitoring, or let's better say condition monitoring. It is diagnostics as well as predictive analytics, all that in parallel by the power of the data, better to say by the power of the information you really get, especially if we compare to the, as mentioned, 4 to 20 milliamp technology with this just a simplex signaling. So if we look to final control elements in the 4 to 20 milliamp world, it's just sending the set point to the control valve. There's not any feedback. And now with APL and the capability to run, as Thilo mentioned, all the protocols in parallel, all the different, let's call it languages and slangs. So there's really the access, the transparent access to anything. And this is a real benefit. All the nice services and useful services we can now establish, implement, and easily run. And it's fully transparent and available everywhere. So this gives really benefit to the process people, to the operators, to the maintenance department, as well as to the management. So full information flow, and as well all the dashboards are now really filled with the real information that is required.
I would say it's the real information with the real timing as well. That's the thing that I get out of this as well. Information for information's sake is limited value. I think from my perspective, I see the market value here is the optimization of the processes, the ability to make better decisions and implement those decisions quickly. Please, Michael, please go ahead.
Let me add one comment. I think it's another very important aspect. Guido just pointed out what kind of new opportunities we have, and there's one aspect that is also very important. I heard that a number of times in presentations from BASF. They have really looked into that very deeply, and one of their statements, and I think that's very interesting, was that Ethernet APL reduces complexity. Mm-hmm. So it's not just that it gives us a whole lot of new opportunities and options, it also makes things simpler than applying field bus instruments, for example. and doing maintenance in plants. So getting up the pure simple process control is simpler than what we have today.
Mm-hmm.
So not just more information, more opportunities, but also simplification, reduction of complexity. I think that's very important.
I always say complexity costs. Okay.
Yeah,
whether it's time, power, or money, it always
yeah.
costs. Exactly.
So
that's interesting.
The statement was exchanging a 4 to 20 milliamp instrument with heart takes hours.
Yep.
And replacing an Ethernet APL instrument is done in 5 minutes. Auto-configure it, self-configuring, very simple, easy. And that's very powerful compared to what we've got today.
Yeah, and self-documentation. This
Yes.
is very important, that there's no more any paperwork, no more any selecting what you would like to get and then searching for manuals. It's all in. This is a service that is already built in and can be easily accessed.
Yeah, Thilo, do you have any inputs on this one?
Yeah, I think when I look where Ethernet, and let's be a bit fuzzy at the moment, Ethernet and TCP/IP-based communication, where it was brought to from vendors, it made it there. So I just have in mind when the internet came to us at home, we had to split. First, it was an analog modem. Then we had to split the DSL signal from the normal telephone voice. And in our days now, we have everything through the same network. We have just one IP connection at home, and it does phone calls. It does Ethernet with all the protocols used for that, and even it can do IPTV. So and this is, imagine this available in the process industry to have just this flexibility. And I think this will unlock a lot of opportunities and sleeping opportunities, which the same as the internet, not everything was known at the beginning. So it was a talking about bandwidth, speed, or today power, but I think we cannot oversee yet what will this all bring to us.
That's a very, very good point. Sorry, go on, Volker.
Yeah, all of a sudden, with 4 to 20 milliamp, device could deliver just one value. With hard, it could deliver some more values, but it was kind of an extra technology on top of it. Now we can not only deliver one value, but a couple values, all in real time, none slower than the other. So out of a sudden, the device gets much more application. We talked about things like asset management, condition-based monitoring, all that, but also for the measurement part of it. So the real, what we call cyclic data in industrial Ethernet. Out of a sudden, a device could have more than one.
Mm-hmm.
So you could think about new concepts for sensors, new devices, new things. There is a lot of innovation that is beyond the protocols, that is just in how to make a sensor. What should a sensor offer? And that is something that I think the industry will explore over the next couple of years.
Yeah, there is a subject called sensor fusion that we could spend quite a lot of time talking about, but I firmly believe that this technology is going to enable these multimodal sensors that give you much greater insights than just the sum of the single sensors. Okay, look, I'd like to move along on to the next question. At the moment at the show, there's going to be some launches for products. I'm seeing a little bit of a lag. I don't think we're going to get all of the instruments available and all of the network products available from day one. So I see a lag between APL introduction and when there will be sufficient equipment, APL-based equipment, to configure a complete plant or process. So does anybody have opinions on in terms of how this gap can be met? I think I'll turn to Michael first because he's probably pretty well placed for this one.
Yeah, there are solutions to do that. So first thing, we will launch our APL switch by end of this month. And so presentation is going to be now, or is now, during ACHEMA Pulse. And there are different ways to fill that gap. So one is that there is a pretty good supply of instruments that are Profibus PA based, and our switch supports connection of Profibus PA devices. It acts as a proxy from Profibus PA to Profinet, and that basically brings all Profibus PA devices on Ethernet APL. Having said that, there are also other options, obviously. In a plant infrastructure that is Ethernet based, you can obviously put in remote IOs to have signals. Sometimes in the beginning we will have discrete signals on remote IOs, but also specialized legacy 4 to 20 milliamp instruments that don't give you the full advantages of Ethernet-based communication, but is at least a migration. And last but not least, I'm not too pessimistic in regards of the availability of genuine Ethernet APL-based instruments. There are quite a few companies working on that. We're going to see we are seeing a number of announcements right now. And I'm very optimistic that there are enough instruments to build a plant that is fully Ethernet APL based by beginning of next year for at least the basic straight functions you need for a plant, and then you can fill in the very special functions with Profibus PA or remote IO. So there's no reason to wait. Absolutely no reason to wait.
Yeah, so that's a good point. And in terms of the remote I/O, I know that we're developing technology called software configurable I/O for this, and it is exactly for that reason, bridging the gap between 4 to 20 milliamps and Ethernet-based systems, and really for brownfield installations. So that's interesting. So I'm going to switch across to Guido at the moment. In terms of the field instruments and actuators, from your perspective, how do you see the rollout going to be?
Yeah, it's really easy that way, due to the fact that, as well, from the point of view to the actuator or final control elements, the idea is to do it with a universal interface. So the APL, so-called positioner, is capable to run at any kind of control valve. If it is linear motion or rotary motion, if it is on-off service or continuous modular control service. So this is very flexible. And in a case that there is already existing instrumentation, as already mentioned by Michael, it's very easy to integrate existing Profibus PA devices, so field bus devices, all via the remote I/O way, the binary and analog signals, the traditional way. So there is not any argument to wait. Let's just start to utilize the services.
Excellent. That's just good input there. Thilo, from your perspective?
I share the optimism and the positive view of Michael and Guido on that one, because I see major vendors are fully committed to APL. There's hard work on the device development. We have heard the first devices will be released already this year, and we know from the vendors they have roadmaps for a reasonable portfolio. So I'm pretty sure we will get to that very soon. Anyway, not all and everything will become available from day one, as usual. So we should not just start in illusion here. So the key is to offer customers a migration path from the today's technology towards APL. So from 4 to 20 milliampere and field bus to APL. And I think this is the key. Michael mentioned one product already on the switch side, and remote IOs play a key role here also to allow a smooth transition and successive transition from 4 to 20 towards APL. So I really be quite optimistic there.
Software looks to be becoming more and more important part of the plant communications. How do you see software evolving, and specifically, what about security? Because that's going to be a hot topic.
Yes, that is the hot topic, because in security, we see these threats every day, ransomware and all that stuff. And out of a sudden, people say, "Oh, wait a minute, my sensor is on the Ethernet," which implies it has connection to the internet, of course, because you want to push data into the cloud and yada, 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 yada. So there are concerns. Now, one thing is for sure, an APL device may run off 500 milliwatts, has very limited computing power compared to a PC, but it is still much more computing power than a 4 to 20 milliamps device, as Thilo said, but it is still limited. Mm-hmm. So to believe that this sensor can fix a bad or weak plant or operator IT security scheme, that's not going to happen. So what is the threat to this device? That needs to be understood. And in my opinion, there are 3 factors. Robustness. Mm-hmm. We are already used to test for robustness, both, for example, with ODVA and Profinet International. There's a lot of robustness testing going on, making sure there is no simple way to use the weakness of a device to turn it against the system. And the second, obviously, is secure boot, secure update, to make sure only the intended firmware runs on a device, which makes it much easier to make sure that no violent player is installed in the sender first place. And the third is authentication. So okay, this message comes from this sensor, and I know it comes from it. There is no way to fake it. The third is addressed by the standardization organizations like Profibus, Profinet International, and ODVA right now for the common industrial Ethernet protocols like Ethernet IP and Profinet. So there is work at different stage to fix that. For the device maker today, the biggest task is to produce a robust device that comes with secure boot and secure update, so that you have the basics done. And I think that is really key to security in APL.
Yeah, I think it has to be in depth. Security in depth is absolute, both physical and software or electrical base. Anybody else would like to contribute to this question?
I just wanted to add, and Volker, you gave me a good invitation to make this comment. I see with APL also that it's not only that the device vendors work together, like we had it on the Profibus or on ART. This group has been extended now to technology providers like you, analog devices, where we depend on hardware, on chips with security engine, with these modern features, because it's obvious that not all the security problems can be solved by software due to the limited communication power. So we rely on powerful chips with these peripherals integrated already. And I think this is for me a big step forward, and what we see through that APL development process already.
What is everybody's vision for the future, for the process plant of the future once it's digitized? What's it going to deliver? What are the benefits, not only to the users, but also to the environment and to the public?
Yeah, to be honest, our vision, or we see a digital safe plant. What means safe? The S for safety and security, as well the A for agility, and the F like flexibility, modular, and the E like efficient. So performing in an optimal and sustainable way. So especially if you look to efficiency for this plant, supported by digital twins. This is a digital part, and as already discussed, APL is the enabler for all these offers. This digital safe plant, digital safe process plant will give us efficiency for energy and resource efficiency. So really to get the step into circular economy, to implement more reliable and energy efficient processes, to think about really the change to renewable energy supply and new media. So we discussed the use of green hydrogen in future process plants, and as well, this is the idea or the future of different process control loops to offer these benefits to anybody. So not just to the end users, to the customers, as well to the environment.
I can only support and agree to what Guido said. Allow me this buzzword. I see the connected world in process industry where basically all and every asset is connected to I don't know, will it be a flat network? But at least from the IT world, we know how to structure even big networks, so that basically even in the biggest plants, every service could access data from any sensor and actor connected to the network. And this will make a difference. The impact to economy and to the environment, Guido mentioned it already, we will see safer plants just due to more monitoring capabilities. We will see an increase in efficiency because of more sensors dedicated to optimization. And finally, when I look, should I say to myself or to us, more automation, and this is a consequence, helps industry in overaged societies as well. Will there be, to keep level of productivity as we know it from today? Will there be in future, will there be enough experienced workers running through the plant which can just, when they walk through the lunch break, to hear how the heat exchanger might get blocked? And running out of these capabilities, this needs to be replaced with modern sensing capabilities, and this requires the right infrastructure. And this is what I see in the plant of the future.
Just some words on connectivity. It's my firm belief, my vision, that every instrument in the field of a process plant gonna be Ethernet IP based. We will see that any other communication will go away. You don't need to be a too big visionary to believe that if you look at our homes, at our offices, at factory automation, where this is already happening or has already happened. And comment to Thilo, when an argument was that there is no educated staff for such things. In the past, people have been asking, where do I connect my amp voltmeter to the terminals?
Yes.
Today, my son, he's asking, how do I hook up my phone to that thing?
Exactly.
They have no idea what an amp meter or voltmeter is. So we really are now creating a technology that is fitting to the education the young generation is getting.
Yeah.
And that's why this gonna be happening, and we have the basics to do that.
The one thing I believe is that we will learn a lot more about things we are doing for 30 or more years already, just by looking at more data that we get from the sensors. That it will be a deeper look into what we do. It is not about generating data, just get enough data and everything will be good. That's not the thing. You have to make your selection, what data is really interesting. Yeah. But now you get to the data, gateways are gone, the hurdles are gone. There are no reasons why we shouldn't be able to get to this extra data that was simply not available before. And that will give us more insights about the processes. I think this is probably the biggest source for growing efficiency in the industry.
Thank you very much. Yeah, I can just conclude with confer with everybody is that the a safer, better, cleaner, more economical, fewer resources. That's the future that APL is going to bring for me. That's my perspective. I'd like to thank everybody for the participation today. It's been a very interesting discussion, and hopefully we can have more of these in the future. Thank you very much for your time.